So, what does a rusty old gate have in common with a stale bag of chips or your grandma's tarnished silverware? I know it sounds like a riddle, but it's actually chemistry. And today we're going to unravel the one single powerful chemical process that connects all of them: oxidation.
So let's kick things off with a bit of an everyday mystery. As we go through these next couple of things, I want you to think about what they all have in common. You've seen this a million times, right? An old bike, a garden gate, maybe a tool you left out in the rain. That once shiny metal surface just slowly gets eaten away by that fleeky reddish-brown stuff we all know as rust.
And hey, it's not just iron. Even really nice things like silver seem to lose their sparkle. A beautiful shiny spoon or a piece of jewelry slowly gets this dark, kind of black coating that just dulls the whole thing.
So we've got the reddish-brown on iron, the black on silver, and now this classic green color you see on things like the Statue of Liberty or old copper roofs. What on earth is the hidden link between all of these changes?
So, what's the culprit behind all this decay? Well, the answer is this one single, fundamental chemical reaction that's happening all around us, all the time. And it's called oxidation.
And this right here is the key. At its very core, oxidation is just about something reacting with oxygen. Yeah, that rust, that tarnish, that green patina, that's just what happens when these metals meet oxygen in the air, especially when there's a little moisture around. They're literally changed by it.
Now, here's where it gets really interesting. Oxidation never, ever happens alone. It's got a chemical partner called reduction. You can think of them like two sides of the same coin. For one thing to gain oxygen, something else has to lose it. They're a team.
So the crucial point here is that this is all about a transfer. In this little reaction, the copper oxide basically hands over its oxygen atom to the hydrogen. So what happens? The copper gets reduced because it lost oxygen, while the hydrogen gets oxidized because it gained that exact same oxygen atom. See? A perfect swap.
Okay, let's put this into practice. First up, our first case file. Let's look at how this whole process causes a huge amount of damage out there in the world of metals.
Now, when we're talking specifically about the unwanted oxidation of metals, there's a special name for it. We call it corrosion. It's basically the slow breakdown of a metal just because of its chemical reactions with its environment, especially with air and water. And this is so cool because it shows how that one core process, oxidation, gives us totally different results depending on the metal. For iron, we get rust. For silver, tarnish. And for copper, that famous green coating. Different looks, but the exact same root cause: corrosion. And this really puts things into perspective. This is not just a small cosmetic problem. The constant fight against rust is actually a massive economic challenge. I mean, it affects everything from our cars and our ships to the actual bridges and buildings that hold our cities together. All right, for our second case file, we're leaving the shipyards and heading straight into your kitchen. Let's see how oxidation affects the food we eat. You know that taste, right? When you open an old bag of chips or maybe taste some cooking oil that's been sitting out too long and it just has that off, unpleasant taste and smell. Well, you have just experienced rancidity. That is literally the taste of fats and oils being oxidized.
So, how do we fight back? Well, food companies have some clever tricks up their sleeves. They add antioxidants, which are like little bodyguards for the fats. At home, we can use airtight containers. But the smartest trick is probably inside that puffy bag of chips. You've wondered why they're so full of air, right? Well, it's not air. It's actually been flushed with nitrogen gas, which physically pushes all that destructive oxygen out and keeps every single chip perfectly crisp.
Okay, so oxidation ruins metals and it spoils our food. It kind of sounds like a total villain, doesn't it? But, well, that's not the whole picture. And that brings us to the bigger story of this incredibly powerful process.
Just think about this for a second. You have the slow, silent decay of a shipwreck happening over hundreds of years, and then you have the super fast, brilliant flash of a magnesium ribbon burning in seconds. You'd never think they were related, but they are. It is the exact same chemical reaction at the core of both. Oxidation can be slow and destructive, or it can be incredibly fast and brilliant.
We've spent all this time painting oxidation as the bad guy, the force behind rust and rancid food. But here's the final twist. That very same chemical process is happening inside your body right now. It's how your cells break down food to give you the energy to live. So is oxidation a force of decay, or is it a source of life? Is it a villain or a hero? The amazing truth is, it's both. And that's something to think about the next time you see a rusty nail or tear open a perfectly fresh bag of chips.